Hi guys, so today we're going to talk about marine geochemistry. What is marine geochemistry and how does it relate to geology? As described on Geoscience Australia, marine geochemistry is the science used to develop an understanding of the composition of the coastal and marine water sediments. Marine sediments, primarily rock and soil particles, are transported from land areas to the ocean by wind, ice, and rivers, as well as the remains of marine organisms, products of submarine volcanism, chemical precipitates from seawater, and materials from outer space that accumulate on the sea floor. The image to the left is basically giving you a visual of that process, representing the nutrient cycling, showing sediments at the bottom of the ocean that bring itself to surface through groundwater inflow and come back out through river discharge and are produced back into the air through gas exchange, aerosol deposition, and brought back into the water through ice and wind. The rock cycle plays a huge part in that process. This image here is basically just showing you an example of how the rock cycle is completed. And sediments and sedimentary rocks are classified by origin of source material and by grain size. Here in this image, again, it's just giving you an example of the formation of the rocks that generally can start as gravel, sand, silt, mud, clay, lime, and soil, and through mineral dissolution as well as mineral precipitation and deposition, those sediments turn into sedimentary rocks and go through metamorphism. For metamorphic rocks that go into a melting process that turn into magma and volcanism that create igneous rocks through crystallization, and the process starts over again. There are actually four sources of sediments and sedimentary rocks. The first one is cosmogenous, which is material that falls to the Earth's surface from outer space. Hydrogenous, which is material precipitated directly from seawater. Lithogenous, which is material derived from erosion of other rocks, typically from continental sources. And biogenous, which is material formed from the accumulation of remains of living organisms. On the next slide, it's basically going to give you images of each one of these types of rocks. In the first example, you're seeing a meteorite falling from outer space, which is giving you an example of cosmogenous, which again is material that falls to the Earth's surface from outer space. The next example is a rock, a hydrogenous rock, which is basically material precipitated directly from seawater. So this rock was formed from seawater. The next example is of lithogenous, which is material derived from erosion of other rocks, typically from continental sources. So you're seeing pieces of rocks on the floor close to the ocean, which is basically coming from continental sources. And then we have biogenous, which is material formed from the accumulation of remains of living organisms. And here you're seeing in the ocean just different sea life that assist in creating those types of rocks. According to the Encyclopedia Britannica, marine geology is also referred to as geologic oceanography. The origination of the seafloor spreading in the 1960s expanded the idea of marine geology substantially. The general realm of marine geology includes mid-oceanic ridges, remnant magnetism, also referred to as paleomagnetism or paleomagnetism, of rocks on the seafloor, geochemical analysis of deep brine pools, and of seafloor spreading and continental drift. In relation to geology, geochemistry is a branch between geochemistry and geology that studies the chemical composition of the Earth, the chemical processes and reactions, and the cycle of matters in the geosphere. Places and Earth features of marine geochemistry. Marine geochemistry primarily focuses on the origin and distribution of sedimentary deposits by water such as rivers, lakes, and oceans, ice such as glaciers and winds, as previously discussed. According to the Geoscience World website, Volume 14, Article 6, marine geochemists are now exploiting new developments in seawater sampling systems, analytical procedures in mass spectrometry to trace elements and their isotopes in the ocean at spatial resolutions and concentrations never achieved before. The new data has already produced new insights into the interaction between ocean life and dissolved trace elements into the sources and sinks of those trace elements. To the left, it's showing some of that process in regards to the isotopes in the atmosphere that's assisting with that data. Marine geochemistry scientists. So when tasked with looking up a scientist regarding marine geochemistry, I was able to read about James Hutton. Now, while the Earth has been studied since the Middle Ages, geology did not make significant advancements until the 18th century when the scientific community began to look beyond religion for answers to their questions. James Hutton, born in 1726 and died in 1797, is considered by many to be the father of modern geology, according to biography of James Hutton, founder of modern geology, through thoughtco.com. Hutton was born in Edinburgh, Scotland, and studied medicine and chemistry throughout Europe before becoming a farmer in the early 1750s. While farming, he constantly observed the land around him and how it reacted to the force of wind and water. James Hutton first developed the idea of uniformitarianism, which is the geological theory that describes the processes shaping the Earth and the universe. He also dismantled the universally accepted view that the Earth was just a few thousand years old. Although James Hutton did not have a degree in geology, he was sent off to the University of Edinburgh at the young age of 14 to study Latin and other humanity courses. Hutton received his degree from the University of Leiden in the Netherlands in 1749, which you could see a picture to the right of that university. It was Hutton's experiences on his farm that gave him the focus to form theories about the formation of the Earth that were innovative at the time. He wrote a book about his theory in 1795 called The Theory of Earth. Hutton's ideas drew much criticism from most geologists at the time because they believed more in the religious theories in their findings. Hutton disagreed with the idea of catastrophes such as the Great Flood. He was working on a book to support his ideas opposing the believed catastrophes and unfortunately died before he completed and published his new book. However, in 1830, geologist Charles Lyell rephrased and republished many of Hutton's ideas in his book called The Principles of Geology, and he called them uniformitarianism, which became a cornerstone of modern geology. Geology is a science that focuses on providing a better understanding of the structure and history of Earth. Marine geochemistry is a science that focuses on providing a better understanding of the composition of coastal and marine water and sediments. While completing a Geology 8 course, I found the correlation between geology and marine geochemistry was in the rocks and sediments that have shaped our Earth. To the right, you can see another image of the process of the rock formations. Here are a list of citations for information that I pulled to bring this information to you. I hope you enjoyed it and that it gives you some insight on marine geochemistry. Thanks so much.